Welcome to this explainer, everyone. Today we are diving into the absolute bedrock of fast, reliable software, data structures and algorithms, or DSA for short. It's pretty fascinating to realize that the secret to lightning-fast search doesn't just lie in better hardware. No, it's actually in the mathematical logic of how we sort data. Mastering this logic isn't just some academic exercise. As you'll see, it's the core foundation for literally anyone looking to understand modern computing. Here's our roadmap for today. We're looking at the origin of algorithms, why data sorting matters, the sorting algorithm arsenal, understanding time complexity, and finally, your career secret weapon. Let's jump right in.
Section 1. The origin of algorithms. It's kind of wild to think of algorithms as ancient, right? But the fundamental logic dates back centuries before silicon chips were even a thought. The very word algorithm actually comes from a brilliant Persian scholar named al-Khwarizmi, who lived all the way back around the year 800. So for centuries, this was purely theoretical, conceptual problem solving. But then, fast forward to the 1940s. With the invention of the very first electronic computers, the study of data structures absolutely took off. Suddenly, humanity had these machines that could execute this ancient logic at lightning speed, fundamentally changing how we manage and process data.
Section 2. Why data sorting matters.
Our source material sums this up perfectly, stating, using the right data structure and algorithm makes your program run faster, especially when working with lots of data. Think about it. If you have just 10 items to sort, you could do it in your sleep. But 10 billion? Yeah, without systematic, efficient logic, your program will literally grind to a halt. The whole idea here is that you simply cannot brute force your way through massive data sets. Choosing the optimal structure and the exact right sequence of steps, the algorithm, well, that's the difference between a program that feels instantaneous and one that completely crashes.
Section 3. The sorting algorithm arsenal.
When dealing with chaotic data, developers definitely don't rely on just a single trick. They have an entire arsenal. We've got bubble sort, which I know sounds like a bath time game, but it's a real algorithm, along with selection sort, insertion sort, quick sort, counting sort, radix sort, and merge sort. Every single one of these represents a completely unique logical approach to taking randomized, chaotic data and putting it into perfect order. Some of them excel when the data is already mostly sorted, while others are purpose-built to tear through completely randomized sets. As a software developer, your job is to look at the messy data right in front of you and choose the exact right weapon. You can think of these tools as falling onto a spectrum. Simple sorting methods, like bubble sort and selection sort, are super intuitive. It's almost exactly like how you'd physically sort a hand of playing cards, just looking at adjacent items and swapping them around. They're fantastic for learning the basics. But then we have the advanced efficiency methods, like quicksort and merge sort. These algorithms leverage much more complex mathematical logic to divide data and conquer it in parallel. They might be a bit less intuitive at first glance, but they are exponentially faster when you're dealing with those massive, modern-scale datasets we just talked about.
Section 4. Understanding time complexity.
So we know quicksort is generally faster for large datasets than bubble sort. But in computer science, guessing simply isn't good enough, right? We really have to ask, how do we actually measure this efficiency? How can we mathematically prove, beyond a shadow of a doubt, which tool from our arsenal is the correct one to deploy before we even write a single line of code?
Well, the answer is time complexity. This is the mathematical logic used to determine how an algorithm's runtime grows, as the data set itself grows. It's essentially a crystal ball for developers, giving us the predictive power to foresee the exact future behavior of our software. It tells you whether doubling the amount of data will simply double the time it takes to sort, or if it's going to multiply that time by a massive factor of 10. By truly understanding the time complexity of, say, bubble sort versus merge sort, you can definitively choose the absolute best method for a specific dataset. It removes the guesswork entirely and replaces it with pure predictive logic.
Section 5. Your career secret weapon.
Now, all this theoretical logic actually translates into a proven, real-world pipeline for you. Step 1. Learn the fundamentals of data structures and algorithms. Step 2. Use that logical problem-solving to totally ace your technical job interviews. Because let's be real, interviewers aren't just testing your memory. They're actively testing your logical problem-solving skills. And that leads directly to Step 3, landing great jobs in top tech companies. Having this knowledge proves you don't just know how to type code, you actually know how to engineer efficient solutions.
What makes this skill so incredibly valuable is its permanence. We all know frameworks come and go, right? New languages trend every single year, but the true value of DSA is that it isn't tied to just one programming language. The logic of a merge sort works exactly the same whether you're coding in Python, Java, C++, or JavaScript. Once you learn the underlying concepts of these data structures and algorithmic flows, you possess a universal toolkit. And that toolkit is going to stay with you for your entire career, absolutely no matter where technology goes next.
So, we've covered the ancient roots, the absolute necessity of efficiency, the vast arsenal of sorting tools, and the predictive power of time complexity. I want to leave you with this final thought. As you prepare for your next big tech interview, which sorting algorithm will be your secret weapon? Will you rely on the simplicity of an insertion sort, or are you going to master the advanced efficiency of a quick sort? The data is out there waiting for you to structure it. Thank you so much for joining me on this explainer, and I highly encourage you to go out and start practicing these concepts today.